All right, so let's look at problem 10, 10.4.6. So for this problem, we're dealing with ANOVA, um, as you may know. And the first part asks, identify the claim and state H naught and HA, alternative hypothesis. Choose the correct answer below. Okay, so the null and alternative hypothesis is always the same. Um, the null is always mu1 is equal to mu2 is equal to mu3. And the alternative hypothesis is always at least one mean is different from the others. So you'll notice that with the ANOVA test. Now it just comes down to which one is the claim. So we'll have to read the problem. So it says, okay, so right here it says, can you reject the claim that the mean price is the same for the three types of treatments? So the claim is the null hypothesis because the claim states that they're all the same. So that's it, part A. Okay, so identify the degrees of freedom for the numerator and denominator, determine the critical value, and determine the rejection region. So we can pretty easily do this by hand. It's pretty easy to do degrees of freedom by hand. So it's the number of, so for the numerator, it's the number of groups. So there's 3 groups and minus 1. So that's how they got 2. And the degrees of freedom for the denominator is the total sample size of all 3 groups added together minus the number of groups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 3 groups, so 12 minus 3 is 9. Okay, and we could. I'm pretty sure we can also get this information from the SPSS output. So we'll see that later. Okay, the critical value for F naught. So 3.01. We'll see how we got this, and the rejection region. Okay, so we'll get this information. As you may know, the critical value and rejection region is based off of the calculator feature on SPSS. So let's open the data in StatCrunch. We don't actually need the data for the rejection region, but we might as well open it because we will need it. Okay, so we want stat calculators, and ANOVA is an F distribution. So we need the degrees of freedom of the numerator. And as mentioned before, that's 2. And degrees of freedom of the denominator is 9. And we need to know alpha, so let's find that. Alpha is 0.1, as mentioned on that first line there. So we want to put that over here, 0.1. It's always a right tail test for ANOVA, so we'll just enter 0.1. Sorry. We want the area to the left to be, well, actually we could just do it like this. We want that to be 0.1, the area on the right side. There we go. So that's how we get the critical value of 3.01 rounded to 2 decimal places. And the critical region is this shaded portion, so greater than 3.01. That's how we get these 2 solutions. And now the test statistic, if you want anything for the hypothesis test, like the test statistic, we need to go into the actual test. So we're done with critical value and region. So we'll go into stat and ANOVA one way. So we'll select the columns, or oh yeah, they're in columns here. So looking over here, which is rows, but select all 3, hold Control as usual, and I think we just compute from here. Let's see here. Yeah, I think so. All right, so there's the degrees of freedom for the numerator and denominator. There you go. So let's see here. 1.143 right here, F-stat. Okay, so there it is. And that's really all the information we need from here. So let's just close this down. So we want to see if the test statistic is in the critical region. So as we can see, it's not, because only something larger than 3.01 would be critical region. So it's less. So it's not in the critical region. So there you go. It's not in the critical region, and so therefore we failed to reject H naught. That's always the conclusion if it's not in the critical region. Choose the correct interpretation. And remember, we want to directly address the claim. So there is not enough evidence. So not enough evidence always if you're not rejecting. At the level of significance for alpha 0.1, to dispute the claim that the mean price is the same for the three types of treatment. So that's what you would conclude. As you can see, it's addressing directly the claim. So yeah, we just want to do as usual and see if what it means to reject, fail to reject H naught. And since we're failing to reject H naught, and H naught is the claim, as you can see, so that's like saying we're accepting the claim. So there's not enough evidence to dispute the claim. So there you go. So that means that we're essentially accepting the claim. Okay, hopefully that makes sense. Let me know if you have any other concerns. So for the most part, this should help you with pretty much any ANOVA test. It's this general process that you're seeing in this video. So let me know if you have any other concerns, and I'll be more than happy to help.